Good day everyone! I'm Cheryl May Zapatero from BSc 1F, and this video is for the completion in the subject Physics for Engineers. At ang gagawin ko today, magbibigay ako ng sample problem regarding sa motion at constant angular acceleration. A disc initially rotating at 3.5 radians per second makes 3 complete turns before coming to a stop. A. Calculate its angular acceleration. B. Calculate the time does it take to come to a stop.
Let's jump into the illustration of the problem. And the problem states that a disc initially rotates at 3.5 radian per second, which makes 3 complete turns before coming to stop. So, dito meron akong gramophone. Let's say that this is gramophone and this is the disc, yung ating bilog dito. And sabing ganon, ito daw ay nag-rotate ng 3.5 radian per second. And ang hinahanap sa atin sa A is to calculate its angular acceleration. And for us to calculate the angular acceleration, we are going to use the fifth equation for the rotational under constant acceleration. And before that, kailangan muna nating i-convert yung ating 3 revolution into radian. Yung ating angular position into radian. So, meron tayong 3 revolution and we know that 1 revolution is equivalent to 2 pi radian, and it will give us an angular position or angular displacement which is equal to 6 pi radian. And yung ating namang equation yung ating fifth equation for rotational under constant acceleration ay equal naman sa final angular velocity square equals to initial angular velocity square plus 2 alpha, or the angular acceleration multiplied by the angular displacement, or yung kinumpit natin kanina. And since kompleto naman na yung ating mga values, is pwede na nating makuha yung ating angular acceleration. And final angular velocity square will be equal to 0. We can cancel this out dahil sabi nga ganun sa ating problem, initially rotating ito ng 3.5 radian per second. But after 3 complete turns, ito ay nag-stop na. So we can cancel this out and we can use the negative. Yan. So now, alpha is equal to negative initial angular velocity square over 2 times the angular displacement. And angular acceleration is equal to negative 3.5 radian per second squared over 2 multiplied by 6 pi radian, which will give us the answer of negative 0.3249 radian per second squared. Ito yung ating angular acceleration. Next is we are asked to calculate the time does it come to stop. So in this problem, we are going to use the first equation, and it is equal to final angular velocity is equal to initial angular velocity plus alpha, or the angular acceleration. Brother! Plus alpha, or the angular acceleration multiplied by the time. And ang hinahanap nga sa atin is yung time na nag-stop na yung ating disk. So, time is equal to final angular velocity minus initial angular velocity over doon sa ating angular acceleration. And for us to calculate that, time is equal to ating final angular velocity, which is equal to 0. 0 minus yung ating initial angular velocity, which is equal to 3.5 radian per second over yung ating angular acceleration, which is equal to negative 0.3249 radian per second squared, which will give us the answer of 10.773 second. So, if we are going to make a analogous on the problem, so yung disk ay nagro-rotate ng 3.5 radian per second at 10.773 seconds. So, yung time na nako-consume niya or yung time na na-consume ng disk para umikot ng 3.5 radian per second ay 10.773, and then tsaka pa lang ito nag-stop. And we must also keep in our mind the difference of constant acceleration equation from translational and rotational. Dahil alam naman natin na sa rotational, laging in terms of radian yung kailangan natin when it comes to angular position. So if degree yung hinahanap sa atin or if degree or revolution yung ibinigay sa atin ng problem, we must convert it into radian.